Alright, we're starting a little early just to let people trickle in. I gotta pull up the chat on my other computer so that I can see the chat. Yeah. Hopefully I'm doing this right so that it saves. Saves, but maybe not. We're going in a second. I can erase this because I sent it already. Let's get started. Well, I hope everybody's quarantine is going okay. What did I do today? Woke up stupid early because of the puppy. Puppy has to go to the bathroom like every 2 hours during the night. So it's like baby practice, I think. And then today we went and picked up some stuff for the baby. We got a crate. We got a no, not a crate. We got a stroller from some people who are giving it away, and toys for not anytime soon, but eventually babies grow up. Do I like orange flavor in candy? Give me an example, because I don't really like hard candy. I'm more of a just give me chocolate. You know? Just give me chocolate. Whatever it is, yeah. Just give me chocolate. I'd rather have that. Rolos, chocolate, just pure chocolate. And not milk chocolate. Milk chocolate's too sweet. No, dark chocolate. Yeah, only dark chocolate. Because, yeah, milk chocolate's, it's not right. Not right. You put milk in your chocolate. I mean, you put milk with your chocolate. Oh, like gummy worms? Blue and red, man. Only blue and red. The other colors taste gross. Which is funny because all the ones. No, not 90%. But yeah, if I was gonna have gummy worms, I'd want blue and red. Yellow and pink? No. Yellow and pink don't make purple. Blue and red do. Hey, Xavier. Gummy chocolate? What's gummy chocolate? No, really, I don't even know what that is. I don't even. Guess I could Google it. What the hell am I looking at? That's weird to me. I'm so confused. Why would you do that to a gummy bear when you could just have chocolate or you could just have gummy bears? Why would you do both? I don't know. I'm not a big candy person. Anyway, I hope your quarantine's going well, and yeah, sucks we can't be together. It's too bad, but I'd rather people be safe than me be comfortable. So yeah, my cat's shitting too. I know I'm not dropping frames, but sometimes the video edits, and I don't know what that's for. So, we've been going for about 5 minutes, so we're going to get started. I'm probably going to start doing that where we just kind of trickle some more sleep guide. So a couple things. I sent an email Friday. I know not everyone got it, so I'm just going to mention it here because who knows? Proliferation. Let's say it as many times as possible. So, homework, right? Turn in late homework, send it to me. I didn't grade this weekend, or sorry, I'm going into the spiel. We'll get to what I said on Friday in a minute. I know I said that I would be grading. I will be grading. Puppy makes sleep difficult, and I don't actually like grading. Grading is not fun for me. So we'll get to it, and I'll get all your stuff in. So that's homework, late homework, old homework, or anything in the Dropbox that was classwork or that kind of thing, right? And then, so that's one portion of your grade, like homework and classwork stuff. And then tests and quizzes, right? That's the other big portion which people have been asking me about. Here's the process. I would first, you should make a study guide. So there are two parts, right? Make a study guide, take Khan Academy test. First, you should make the study guide because I want you to study, and that's a way to study. So you're going to make up problems that cover comprehensively everything from the chapter, and you should have a textbook at home. So you should have ways of doing that. I'm not always looking at the camera. I'm used to that. So you're making a study guide. You have a textbook to help you. They need to be your original problems. So if you're copying problems from the textbook, that's not doing what I want you to do. Also, just taking problems from the textbook and changing the numbers around, also not really what I want you to do. You need to make up problems that represent the concepts from that chapter. So if you're doing chapter 7, or whichever chapter, you're going to go to that chapter in the book, go online, look up, research things about it, and then make a study guide. There's a chapter test at the end of the chapter, right? So that should help you, give you an idea of the important things that need to be on the test. Also, a lot of you took the test already if you're retaking it, so you should hopefully remember what's on it a little bit. So you're going to make a study guide. You need to solve all those problems. So you need to solve all those problems. So not only make up the problems, but also show how you would solve them and explain them. And so writing a problem and then give me the answer, not good enough. Then you're going to go on Khan Academy and you're going to find the closest test that's like that chapter. So Khan Academy is broken up into sections by subject, which means it doesn't exactly align to the tests that we took in class, which is fine. But you're just going to find one that's close. So like logarithms, you're going to go to the logarithms section. Take the chapter test for logarithms or the chapter quiz for logarithms in Khan Academy. Tell me you took it, and then we'll tell me, and I'll look at it and I'll grade it. So I'm going to combine those two things, the study guide and the Khan Academy test, which is more work than just taking the test, but also probably should have been taking those things before we left. So that's the plan. For redoing assessments. The other thing that is anything else I need to talk about? I don't think so. That's it. We're gonna jump into chapter 8. I want to. Can we finish chapter 8 this week? Maybe it'll be this week or next week. And remember, like, we're not having a final anymore, because I'm not having any grades. Everything's just reading. So you don't need to worry about that kind of stuff. I had people in geometry ask me if they were gonna have to take a final. I was like, I don't think you've been paying attention. When are we going to do Fibonacci sequence? That would be this chapter, I think. I think that's this chapter. I might just spend some time going over it, because I think it's important. But I don't think we'll do that today. That is not the Fibonacci sequence. That's a geometric sequence, though, which is what we are going to talk about. Is there anything else I wanted to go over before we jump into things? Oh, we're going to do some review. So the homework, there wasn't practice. From kind of now on, I'm just going to be like, here's some practice problems that you can do if you want to stay on top of things and kind of prep for next year and continue to get good at math. I'm going to assign things, but they're not really assignments like normal, right? They're just practice. So you don't have to do them, but they might be good. Okay? I'm not going to grade them all. You don't need to send them to me. Please don't. That would actually confuse me while I'm trying to grade. So things we should talk about: summation, notation, and algebraic sequences, or arithmetic. So we're going to switch to this gamma here, and hopefully this goes. Geometry last hour wasn't awful, but I'd like to improve every time we do this. So we're going to sum an arithmetic sequence. The rule is going to be 3. Now, normally, if we were in class, I would just say, give me a number. Shout it out. 3x minus 4. That's the rule. And we want to sum from 11 to, I don't know, something crazy. 34. Because we don't want to do this by hand. We're not going to do all those numbers by hand. We don't want to plug them in and have to solve them. We're going to use summation notation. So I'm going to rewrite this in the notation. Right? This doesn't start 11. This is 11th term. So you would plug in 11 for x and get something. So our summation notation is going to look like this. We're starting at I equals 11. We're going to 34. Our equation is 3i minus 4. 71. Yeah, I don't think so. So we're going to plug in 11 for our first term. We're going to find our last term. And then we're going to use the common difference to average them. I'm blanking just a little bit. So we got to plug in 11 here. So 3 times 11 minus 4. So 29. And then we're going to plug in 34. And I would use a calculator, but I'm pretty sure it's 102 minus 4, so 98. So we would plug in 3 times 34 minus 4, which is going to give us 90 and 12, so 102, and then we subtract 4, so this is 98. So our first term at 11, our 11th term, is 29. And then our 34th term is going to have a value of 98, but we want to add everything in between those. And we're going up by 3 every single time. Oh, no, I did this. So we're going to add them, 29 plus 98, take the average, and then we need to multiply this by the number of numbers. So normally, we would count it on our hand. You want me to make shirts? Yeah, we can do that. Mugs and shirts and sweatshirts and, gosh, no, I have no interest in doing that. From 11 to 34, right? Normally we would count our hands, but that's a lot of numbers. So I just want to remind you how we would do that. Okay, so if we were going from 1 to 5, we'd go 1, 2, 3, 4, 5. There are 5 numbers. If we were going from 3 to 5, 3, 4, 5. There's 3 numbers. We don't subtract them. If we subtracted them, we would get 2. But to go from 3 to 5, we go 3, 4, 5. So there's 3 numbers. So what we do is we subtract and we add 1. So 34 minus 11 would be 23. Plus 1 is 24. We're going to multiply this thing by 24, and that gives us sum from our 11th term to our 34th term. Okay, so then we would take that and we would go to this screen, and we would not look at the next stuff, but we would just plug in here. 24 times 19 plus 98. Oh, what do I do? And plus 98. And then we're just going to divide that by 2. And so that gives us 1,524. 1524. Okay, so our answer is 50. So this sum is equal to, where is this thing? 1524. Right? So that's kind of a review from what we did on Thursday last week. The homework is a lot like that. Right? Okay, so now what I want us to do is we are going to start the next section. The next section is geometric sequences, so we're multiplying every single time. That's what we're multiplying. And there's some other formulas kind of like this thing that are going to help us. Okay, so in the textbook, let me switch to this again. In the textbook, it's going to be section 8.3, which starts on page 425, and we'll do some of the problems here. Now, if we summed all the values in a geometric sequence, usually they go to infinity, right? We're multiplying 2 over and over and over. So 2, 4, 8, 16, all that stuff. It's going to get really big because we're multiplying every single time. It's going to go to infinity. But we just want to add a few of them. Okay? And so we're going to come up with a way to write that. Okay? And then, so we're on page 425. And then also in the Dropbox, I put in the student journal pages. Not all of them, but some of them. So we'll look at these things. They have kind of our core concepts. This is the important thing that you need to know by the end of today. That little section. How to use all those letters and those things. The other thing is there's practice problems here, right? We might do some of these, or they're just available for you to use. Okay? Not sure. I don't. Okay? We're going to start with what a geometric sequence is. Okay? So a geometric sequence uses a constant ratio. Geometric. You think like geometry, they're kind of connected. I think the root word comes from a different language. Geo. No, they should come from the same thing. But they have a different context here and there. In the context of geometry, we're talking about space. Here, we're talking about multiplication. So arithmetic, we are adding over and over. And here, we are multiplying over and over and over. So a sequence is just a list of numbers. And, this is a big part of math, lists of numbers. Maybe not a lot of math you've done because you've been doing algebra, which is like adding and subtracting things. That's fine. But sequences, very important. So here's what it's going to look like. We're just going to talk about what a geometric sequence is. The common ratio is going to be what we're multiplying by. So before, for arithmetic, it was common difference because it was the distance between the two numbers in the sequence. Here it's the common ratio, so we're either dividing by something over and over, or we're multiplying. So it's the ratio in between. So when we divide the two numbers, we should get something in common between them. So for example, if we go to this screen, tell whether each sequence is geometric. We're in example 1, this. Okay. 6, 12, 20, 30, 42. Do they have common ratio are we dividing by something every single time? What we're going to do, we'll do this first one. It's 6, 12, 1, 32, 32, and it keeps going. And it keeps going. So what we need to do is we're going to check if I divide each number by the next number, do I get the same thing? So is 12 divided by 6 the same as 20 divided by 12? So we're going to take this number divided by that number, this number by that number, this number by that number, this number by that number. So it's 12 divided by 6, which is 2. Is that the same as 20 divided by 12, which is not 2. This is 5/3. Both have a 4 in common that we can divide out. Okay, and then we would divide the next thing. 32 divided by 20. Already we know this is not geometric because they're not the same. We would do 32 divided by 20, and that would give us 3 halves. So 2 does not equal 5/3, which does not equal 32, so it's not geometric. Okay, so we're just dividing the numbers and seeing if the thing that we divided is the same, or the result of our division. In other words, if I multiply 6 by something to get 12, 2 presumably, multiply 6 by 2 to get 12. If I multiply 12 by that same number, do I get 20? If I multiply 12 by 2, I don't get 20. If I multiply 20 by 2, I get 32. The next one, though, remember I'm going to go maybe a bit quick. I'm going to kind of take some pauses just because my voice is getting swollen. But you can go back in the video to rewatch what I said, what we wrote. If you missed it. 256, 64, 16, 4, 1. And now, really, we don't need to write this out every single time. We can just check. But when I divide these, 64 by 256, which is a quarter, and 16 by 64, also a quarter. That's right, and 4 by 16, which is also a quarter. I always get a quarter, so it's geometric. Geometric sequence. We're multiplying each number, 256 by a quarter, 64 by a quarter, 16 by a quarter, and so on. Okay? So that's how we could tell if they're a geometric sequence or not. Okay? Now, what if we wanted to sum everything or write the rule? So, just looking at a sequence is not easy. We can even make them up. Right? These are ones I got from the book. But if I wanted to make one up, we would just multiply. So maybe I start at 3, and I'm going to multiply by 7 every time. It's going to be huge, guys. 21 times 7, 147. Yeah. 140 and then 7 times another 7. It's going to be a really big number. Alright, so we're going to multiply. Now, what if we, just like before with arithmetic, we added them together? What if we added them together? Well, we got 2 rules, and those are in. Oh, come on. Those are in your student journal pages in the Dropbox. Okay, there's 2 rules. And then there's the thing. What we're going to be doing is we're going to be using an exponent to write our multiplication over and over and over. So we have our first term, a sub 1. This does not highlight very well. But that a sub 1, that's the first number in our sequence, whatever it is. Then the next number in the sequence, we're going to find by multiplying by our ratio, r. And then we do that as many times as this says up here. We multiply as many times as it takes to get our next number, n minus 1 times. When we start at 1, that turns into a 0, so it's just our first number, a sub 1. And when it's 2, we multiply by r once. Okay? So, not write that on Word, but we're going to do whatever value we want. Maybe we want the 50th term is going to be our first term times our ratio times n minus 1. So we'd put in 50 here, multiplying by r 49 times. Quick clap. This one. That's my keyboard. It's the switcher for the things. So, sorry. I can't fix it. Well, maybe I can fix it tomorrow. But all right. So here. Go like that. No, okay, so example 2. We're on page, if we're in your textbook, this is page 427 in your textbook. Writing a rule for the nth term. So we want to find a rule. This thing. The rule. There'll be letters and numbers here. And we want to find it when a is 8. So when we plug in 8 for n, what do we get? Our sequence is 5, 15, 45, 135. So they're telling these are already geometric. Sometimes, towards the end of the chapter, or if I was giving you a test, I would have given you a sequence and you would need to figure out, is it arithmetic or is it geometric? Does it add every time or are we multiplying every time? So here's what we're doing. Oh, that's the wrong thing. Dox people. How did that work? Dang it. There we go. All right, so it's 5, 15, 45, and 35. Now we can just multiply by hand every time by 3. All right, 5 times 3 is 15, 15 times 3 is 45, 45 times 3 is 135. We multiply by 3 every time. Or we're going to make a rule. So here our rule is our first term. First term was 5. Is this 1? That's a beautiful position. Thank you. I've been practicing. And then our ratio is 3. We're multiplying by 3 every single time. And then our variable goes up here and it's n minus 1. Okay, so that's our rule for this sequence. And then we want to find a sub 8. We're just plugging 8. Okay, so 5 times 3 times 8 minus 1 is going to be 3 to the 7th. 5 times 3 to the 7th. So we would go to our calculator. 5 times 3 to the 7th power. And that's a really big number, which is not surprising because we're multiplying over and over and over. So typically, geometric sequences become very large quantities. Which, if you remember back to last chapter or the chapter before, when we were talking about bank accounts and interest. We want to multiply over and over because that makes our bank account become as large as possible. Oh, I didn't switch. Okay. So that's the 8th term. If we multiplied by 3 7 times, this is where we would eventually get. We're going to do the other example of this, and then we're going to talk about what if we wanted to add it all together. Or maybe it's no. There we go. Okay. All right, so our next sequence is 88, negative 44, 12, and negative 11. So it's switching between negative and positive every single time, right? And we're also dividing by 2. So our ratio is negative 1/2. Okay. That's our ratio. That's going to be R. That's going to go here in our formula. So in our rule. So A sub n is going to be our first term. Oops, where's the 88 times negative 1/2 to the n minus 1. That's the rule. Okay, and then you want to know A sub 8 or A sub anything. Maybe 88 times negative 1/2. 8 minus 1. Okay. So I would not do that by hand. I would plug that into the calculator, and I just realized that you didn't see the work I did. Typical. Yeah, still getting used to it. Sorry, guys. So we have our sequence here. I'll talk through what I did. We have the sequence here. 88, negative 44, 22, negative 11. We're dividing our common ratio. We're dividing by 2, but it switches negative to positive. So our common ratio is negative 1/2. We're multiplying this by negative 1/2. We're multiplying this by negative 1/2. Multiply, so on, so on, so on. Okay. And then our rule is going to use these numbers here. We start with the first term. This is A sub 1. It goes here. Our common ratio is R. It's going to go here. Negative 1/2. And then n minus 1. So we plugged in 8, and we need to plug that into the calculator. So it'll be 88 times negative 1/2 raised to the 8 minus 1. And so that gives us negative, it gives us a decimal. This is also a fraction of negative 0.06. 0.65625, which is the same as negative 11/16. Okay. Okay. So that's writing a rule and then finding a value. So like the 8th one. Is this not new, Alexis? Am I crazy? I thought we hadn't done this. Because, well, it's basically the same thing as arithmetic. but we're multiplying, so there's an exponent. So I don't think we did this before we went quarantine, but it should feel the same. Because it's basically the same thing. It's just multiplying. Yeah, it's the same. Now, it's going to be different right now because we're going to add these values together. If we want to add from 1 to something, it's a different formula than we were doing before. So that's kind of the difference. Okay. All right. Let's see. We're not worried about writing a rule given all these situations. What we want to do is we want to sum geometric sequence. Now, in class, I probably would have had to, or not had to, in class, I probably would have proved this formula. I'm going to spend time doing that. I'm not going to do that because we got 10 minutes and you can look those things up online. Okay, so if we go back to our student journal, which is in the Dropbox, there's this sum of a finite geometric sequence. Now it has to be finite because if it's infinite, usually they don't converge to a number. They usually blow up. Okay. So we're going to use our summation notation, but instead of the equation being linear or looking like a line, it's going to look like an exponent. And then we're going to take this formula, solve it. This one right here. So the sum formula is this. The sum number is the first n terms. So this starts at 1 and goes to something. Unlike the addition ones, we're not going to start at like 20 and go to 25. Yeah, we might, but not think it is. We're going to start with our first term. Whatever the first term is, times 1 minus r to the n. So our common ratio, whatever we're multiplying by, raised to the number of things we're counting, divided by 1 minus r. Okay, that's our formula. That would give us the sum of a bunch of numbers. So if we go back to our, here's our example. Sum, and I'll do probably a couple of these. Okay, 1, we're going to 10. Here's our formula. Our first term is 4. 3 raised to the k minus 1. So here's our rule. So we can take the information from the rule, and we're just going to plug it into here. And it will tell us all the values. And n is this number here. So we're looking for s sub 10. This is a 10. So s sub 10. This is going to equal a sub 1. The first number is 4. So 4 times 1 minus r to the, not r, I'm sorry, 1 minus 3 raised to the nth power. So that's 10, 3 to the 10th, divided by 1 minus r. So that's another 3. Okay, so I got the 4 from here, got the 10 from there, and then the 3 goes there. Same thing with the 10 over here. And the 3 doesn't. Probably couldn't make these no messes. Okay, so then we would just plug that into a calculator. So this. 4 times 1 minus 3 tenths. Put these in double parentheses just to make things a little easier when I do this division. And 1 minus 3. It becomes a really, really large number because we added a bunch of things that multiplied it. 118,096. 118,096. Okay, and if we were to look at our text to double check, that's what they got us. Okay. Okay. I'm going to do another one of those. And then we'll be finished. Okay, so I remember Alexis asked me about a problem that she was working on, and it was geometric. And so you're trying to add things together, she used the other formula, and it definitely does not work. Alright, so here's what we're going to do. We're going to go from 0 to 13. Not 0. And we're going to be multiplying. We're going to start at 3, and we're going to multiply by 3 halves every time. We're going to go from 4, and we're going to multiply it by 2 thirds every time. Here's our rule. We're starting at 1, we're going to 13. Okay. And so we're just going to plug stuff into the formula. Because the first term is 4. So S sub 13 is 4. 1 minus 2 thirds to the 13th. And this is definitely why we'd use a calculator. And we're going to divide that by 1 minus 2 thirds. Okay, so I took this formula here, this thing with all the letters. I took a sub 1, it was the first term, so I'd have a 1 on the bottom. The first thing, that's this 4 from our rule. This rule is the same as this formula here. So the 1 is the 4, so I put the 4 and the 4. And then the ratio is 2 thirds. I put 2 thirds in for R, and I put 2 thirds in for R. That's all I got this. Okay, and then N is just how many numbers are we going to count? How many numbers are we going to add together? And then first one, the second one, the third one, the fourth one, the fifth one, the sixth one, the seventh, all the way up to 13. Counting up to 13. So I put in 13 here. And then don't do by this by hand because we're multiplying a bunch of 2 thirds together. You're going to want to use a calculator. So Desmos, we started at 4. Parentheses, here's the top of my fraction, 1 minus 2 thirds to the 13th power. So that's the top of the fraction. Whoop, top of the fraction. And then we're going to divide the top of the fraction by 1 minus 2 thirds. I don't really like it. And then we get that. $11.9383 going on. And the reason it's so tiny is because when we multiply it each time by 2 thirds, the number starts getting really tiny. So it gets really tiny. Even though we added 13 numbers together, eventually they're not very big. because we know 25 to 13. So it's not bigger than 13. All right. I think that's all I want to do now. Yeah, that's it. So, any questions? Now would be a good time to ask them in the chat. In a second, I'll tell you what the practice problems are. What the practice problems are, and we can. You don't have to do those, right? They're not for a grade. But they'd be good practice if you're stuck, or want to just be better at it. Also, pretty sure this is on Khan Academy. If you want to watch someone who's done videos way more than I have, they exist out there in the world. So I'm not the only one to learn from. Right? Certainly not. I'll be grading this week, probably tomorrow, I think. Maybe some today. And yeah, if we don't have any questions, I'll wrap it up. The puppy is asleep outside, so I'm not gonna grab the puppy. She has such a tough life. I said sarcastically. Which practice problems do I want you to do? Midnight Gospel. I think the cat is asleep and doesn't really like it when I pick her up, so she's indisposed. Xavier wasn't listening. Okay, so the practice problems are going to be page 430, and I'll show it on the whiteboard in a second. 430. You can, Maribel, you can send them to me, but you do not need to. They're not for a grade. They're just for you if you want to practice. Also, the student journal is in the Dropbox folder if you want that. So, what was I doing? 430, 5 through 8, 11, 12, and then some stuff. 47. So this is more problems than I would normally give as homework. But we're not meeting until Thursday, so 2 or 3 days to do it. Yeah, so 5 through 8, 11, 12, 47 through 52. I will send a remind with that in it, but, you know, on a weird time. It's not mandatory. So, if you don't got any more questions, I think that's it. I do miss you guys seeing every day. Like, what is this weird thing that we watch? Midnight Gospel. Oh, it's a cartoon like Adventure Time. I'd probably enjoy that. I don't know that my wife would like that. Is the Microsoft Teams still open? I don't know what that means. There is a Teams page. I don't really use it that much. So, yes, I think. I don't know if this is really my kind of show. I never really watched Adventure Time, so it seems like the comparison. Oh, and it's like R-rated. Not that I'm sure that should be. We'll see. Meh. None of your other teachers have contacted you? That's kind of disappointing. The dog, I will. Here's what I'll do. I'll send some pictures onto mine, or I'll send a picture. But she's outside sleeping right now. I don't want to bother her. She'll whine. And I think that's it for today. Unless you guys have more questions, I'm gonna send that reminder. Send this to all the other 2 students. We're going to use the video and be like, what's Mr. Martens doing? It's so boring. This is why I don't stream. Fridge reveal at 100 subs. That's fine. Yes, Sticker, I'm going to grade your stuff. No promises about what that will do to your grades, but I will grade it eventually. Practice problems for we are in 8.3. Page 430. 5, 8, 11, 12, 7, 2. Yep. Okay, I'm going to end the stream. I will see you guys on Thursday, and we'll continue chapter 8. I want to be done by next week, because I want to get to the other stuff. Because it's all trig ratios and trig functions, and those are actually interesting. So, I'll see you guys on Thursday, same time, 2 o'clock. Probably have the puppy on Thursday, I think. I'll plan that time better. And talk to you later.